welcome. Thank you so much for staying till the very end of the day. We know it's probably been a long day for you guys already, so thank you very much for giving up your time and not leaving and coming to our session today, all about platform engineering, looking at how do we enable that in our own organizations, what advantages can that give us, how can it help us as developers, all through sort of building internal developer platforms. So hi, my name is Grace Jansen. I am a developer advocate at IBM based in the UK, and I'm speaking today with Maarten.
Yeah, I'm a specialist solution architect within Red Hat, mainly Belgium, Luxembourg as a region, and then specialized solution architect that's in AppDev and AI.
Fabulous. So we're going to dive straight into this. The first thing we should say, though, is we do have the Slido link, so you're probably familiar with this from other talks throughout today and yesterday. If you have any questions throughout this session today, please feel free to visit the Slido, add your questions in, and then we'll look at them right at the end of the session. We have got the page up, so we will be visiting it. I'll leave that up just for a second in case people want to scan it. And it's gone. Cool. All right. This is probably my favorite slide, and hopefully you will enjoy this. It will wake you up a bit at the end of the day. If you've not seen Toy Story, make that your take-home for the day. Go and watch Toy Story. What a great movie that is. Why are we trying to build cloud-native applications when it can be really hard and frustrating? And I think it really boils down to, as developers, this feeling of, ooh, the cloud. We get excited about building for the cloud because the cloud offers us capabilities and benefits that are really hard to get when we're doing things on-prem. Things like flexibility, portability, being able to have innovations at our fingertips that would be much harder to get were we doing it on-premise. So we get excited about developing for the cloud, and that's why really we want to try and move our applications in that direction and get them to be as cloud-native as possible. But it doesn't always feel like that. It often feels more like this. It can be frustrating. You get the classic, well, it worked on my machine, and you don't really know why. It doesn't always feel as happy as this slide before. So today, we're hopefully going to be helping move away from stressful Sheldon and back towards those happy aliens. Today, we're going to be taking a look at how we got to this place, what struggles we're facing. We're then going to go into what is platform engineering and how can it help with those struggles that we face. We're going to talk about some key topics like internal developer platform and internal developer portal and the differences between those key terms. And then we're also going to take a look at the benefits they offer. Finally, because we're developers, we're going to have a live demo. Nothing can go wrong. We're going to pray to the demo gods that this works, and we're going to showcase how you can utilize tools to be able to introduce this into your own organization and some of the tools that are available out there for you to do that. At the end, we're going to have a summary and lots of resources, because who doesn't love loads of homework afterwards? So if you do want these slides afterwards, we will be sharing them, but you can also take screenshots or photos with your phone as well. We've got lots of links to share. Okay. So without further ado, we'll dive straight in. What on earth happened for us to get to this stage? Many, many things. Firstly, we've got this trend of this shift left trend. We've got this increasing cognitive load coming onto us as developers. You build it, you run, hopefully not away, but you now have to run it. I quite enjoyed this meme. We'll come back to this later. Now, we're not just as developers focusing on app development. No longer are we just doing dev or ops. We then moved into DevOps, and that evolved to MLOps. Suddenly, we got DevSecOps, and we got this humongous one now of DevBizSecFinMLOps. I'm not even sure what that is. But we've got this growing list of responsibilities falling on our shoulders as developers that we now have to be accountable for, adding to that cognitive load that we have to think about of which tools do we use for each, what processes do we put in place for each. So it's a lot on our shoulders. And what does that mean when we look at organizational impact? If we take a look at traditional app delivery, we've got very happy devs, not so happy ops. If we take a look at the key here, we've got ops' sort of responsibilities in dark blue, which you can see is starting to be the majority of that list. And we've got development responsibilities in the light blue. So happy devs, because they're able to just focus on applications and building cool stuff. But ops are a little bit overwhelmed because they've got a lot to deal with here in this traditional app delivery. Moving over into more modern app delivery, now we've got more stuff to think about, things like usability, observability, quality as well. Now we've got a sad dev because we've got even more on their shoulders, and a bit of a confused ops because we're starting to get a merging between dev and ops. The responsibilities aren't as clear anymore as to who does what, and it gets a bit confusing. So not really anyone happy in this picture anymore. As well as the cognitive load increase that we're having on developers, we've got so many tools that we have to choose from for each responsibility that we now have. Just for fun, I got up what I like to call the cloud-native grocery store, and just for a laugh, I've put Where's Wally in it, just to cheer you up today. So can anyone, I'm going to give you a couple minutes, can anyone actually spot Wally or Waldo in this picture? Yeah, a couple of hands, nice, a few people have spotted him. It's a challenge for a reason, because this is huge. Just in case you hadn't spotted him, here's the answer, because I know it can be annoying. This just shows you the huge array of different tools there are for the different stages and responsibilities and tasks we have to do now as developers. It's a nightmare to try and navigate. It's humongous. So trying to pick the best tools for each individual task here can be a real challenge. And again, adding to those cognitive load. As if that wasn't enough doom and gloom, there's more. More developer struggles that we face now, especially with modern cloud-native delivery. CI/CD tooling. I really enjoyed this image because it really summarized how I felt learning cloud-native. You think you're starting to understand containers, then you discover Docker, it's getting exciting. You start understanding Kubernetes, you think you're at the top, and you realize there's a hell of a lot more to cloud-native that you've still got to learn. So it's a really steep learning curve that we're trying to sort of tackle and understand and get our heads around and get comfortable with. Not only that, as well as it taking a lot of time to learn this, the options just keep changing. There's so many new tools coming into play. We're having to try and keep on top of not just this whole process of learning, but also the tools that enable us to do this as well. As well as that, we've got open source standards to consider. Are we being compliant? There's so much involved in this. Another one is container management. As we're moving towards the cloud, a lot of us are utilizing container technologies, and whilst that offers benefits like portability and flexibility, it also offers a lot of challenges, and again, more cognitive load on our shoulders. Which tools are we going to use for this? How do we configure our environments? How do we ensure they're all the same? What builds how are we going to build our application? So it can be really challenging when using containers to remain consistent and to stick to those best practices. Now, there are tools that can help with that, things like operators and build packs, but again, still challenging and another thing we have to consider as developers in this modern environment. As well as that, we've got things like security and regulatory threats and requirements. I quite enjoyed this image. Threats everywhere. Just more positivity here. So, the fact that we have to be compliant and aware what's in our application. As we're utilizing more and more open source, we have to be aware of, are we using a software supply chain that is compliant, that's secure, that we trust? So being able to understand what's in our source code, what's in our image, what's in the external libraries and the third-party libraries that we're making use of. And understanding, do we have a trusted supply chain? Do we have any compromised credentials? Are we doing effective authorization and authentication as well? And again, there's more. As well as all of these challenges, as developers in this modern day, we're probably also facing these challenges too. We're likely drowning in scripts, for example, and maintenance costs, can't reach the degree of automation that we really want to. We often have key person dependencies to be able to get environments in place. Creating a new environment can be a really long process, and if that key person is missing, again, even longer, and environments can get blocked in testing. So if you're a little bit dramatic, like I am, it feels a bit like this. I just don't want to do it anymore. It's really hard, it's annoying, there's just too much. So hopefully, it's not all doom and gloom in this session. We are going to be helping you with this as we go along. But it's not just me saying this. This is reflected in many different industry surveys that have been conducted. I'm not just being overly dramatic here. Other people are agreeing. I quite enjoyed this survey by Luca on X or Twitter, whatever you want to call it now. where he's like, devs, be real. Do you guys actually want to be doing these ops stuff? And if you actually combine the no and the slightly ruder no answer here, it outweighs the yes. As developers, we want to be able to be focusing on developing cool stuff within our applications. We don't necessarily want to have to be dealing with all of the operations side of things and those extra responsibilities I was talking about. And as you can see here, some of the surveys, again, some of those top 3 causes of developer burnout, as you can see here, increasing workload that we were talking about, placing on our shoulders, pressure of digital transformation, having to learn all of those new skills, requirements for that as well. These are the top causes of developer burnout. So, as I said, it's a little bit doom and gloom so far, but we are going to be helping you overcome these struggles. So how do we do that? Over to you, Martin.
So yeah, I don't think it's a surprise, hence the title of the talk, but platform engineering is there to help. So what is platform engineering? In a nutshell, it's enabling self-service capabilities for developers and abstracting away the underlying complexities of the infrastructure and abstracting application configuration. It's often put in combat with DevOps, but it's not really combating with each other. Because, yeah, platform engineers, platform teams, will make use of DevOps principles to build the platform. So how does it go? Well, you start with making the recipe, which is listing the requirements, the capabilities developers need to build later on in the platform. Here it's already an important thing that you listen to the developers, what the issues are, what the challenges are that they are facing, that you are building a platform for them and not just pushing something to them because adoption rates will be rather low. So what can be these recipe ingredients? Can be, for example, runtimes and frameworks that you enable, orchestration tools if you're doing microservice development, some kind of CI/CD tooling, and so on. Whenever you have the recipe, you go to the second phase, which is baking the platform. Now the infra ops security people come into play, and for every required capability, they pick one or multiple components from, for example, the cloud-native grocery store they have at their disposal. For example, on the CI part, they can use the good old Jenkins together with Tecton pipelines or GitHub Actions. So how does it look like? You start from the recipe list, the capabilities that you require. You bake it into a platform, but then you still have the issue, which we call bookmark hell. It means you have a lot of application interfaces to interact with. Let's say for every repository that you have one or multiple CI pipelines, a couple of CD pipelines as well. You have documentation all over the place in Confluence, SharePoint, Teams, name it. And there are all application interfaces that you need to interact with. Now with an internal developer portal, you put a single interface on top of this bookmark hell, and it is then the single entry point to the internal infrastructure of your organization. So as a summary, the internal developer platform, Grace, it's an IDP, right?
Yeah, it's really important noting here, guys, that it gets a little bit confusing when you start reading the literature around this because we're developers, we're in tech, we love acronyms. It's like speaking in Latin half the time, especially in large organizations like the one I work in, IBM, we're full of them. It's important to note here that in this case, we're using Internal Developer Platform, IDP for that acronym. You might read articles that use IDP for Internal Developer Portal. So just make sure when you're reading literature around this subject that you're being clear on which one they're referring to with IDP. I mean, I think there's also other stuff in tech that has the same acronym. Yeah, exactly, identity providers. So yeah, we're just being clear here in this presentation, we're referring to the platform, not the portal.
So as a summary, the platform is the central collection of tools, services, and workflows to give self-service, to give an abstraction on the underlying infrastructure, and to give an abstraction on top of the application configurations. Why is this important? For example, if you remember the start of the cloud era, you had an Amazon Azure console given to a developer. If he then wanted to create a database, he still required some knowledge on how to maintain it, how to get it up and running. With the abstraction layer, you can say you just select the database type, for example, Postgres, and some t-shirt sizes to do the sizing of the database. And that's the only thing that's required for a developer to start up a database. Hence the abstraction layer on top of the infrastructure and the added value of a platform. Then the portal, that's nothing more than the single interface on top of all these application interfaces to interact with the underlying infrastructure, as we will see in a second in the demo. So again, be aware, platforms and portals are two different things. But Grace, yet another tool. I hope it comes with benefits, right?
I should, otherwise, why are we here? So, as Martin's talked about, we're sort of introducing these extra components, these extra layers in not just our application development process, but also in our applications themselves. So, what benefit is this going to give us as an organization? And as you can see, happy faces all round. So now, by introducing this middle component here, platform engineering, as a separate team or squad, what we're able to do is clearly separate out the responsibilities and abstract away most of sort of the more traditional ops stuff of picking those ingredients that Martin was talking about, picking those different tools for each stage of our development lifecycle. So now developers can focus on developing great, innovative applications. The platform engineers can focus on, okay, what are we using to build our application, to deploy our application, what runtime are we using, where are we getting our Java from, and our ops can focus on things like guest virtualization, the OS, the hardware, and the entitlement and billing. Now, it's important to note here, where does this platform engineering team come from? Martin, does it have to be new hires?
Doesn't necessarily needs to be new hires. I think it brings added value if it aren't by default platform engineers. For example, I think it brings more value if you have developers, infra, ops, sec people, and then mainly the senior people coming together in some kind of platform team. Because on the dev side, they can list the challenges because they see it on the field. And from platform engineering to dev, they can advocate for the platform, hence higher adoption rates. On the other hand, ops, infra, security, you will need them to build the platform. So you can have platform engineers, nothing wrong with that, but I think the true power is that you bring together the silos that are there in the organization.
Yep, so it doesn't necessarily have to be new. So we know a lot of organizations aren't, the Netflixes of this world, and that we might have smaller teams. So being able to pull together members of your own team to create these squads, to sort of have this separation is also a possibility. Now, we know that a lot of the time, it's not just about those qualitative feeling responses of our devs are happier. It's also important that we have sort of those base bottom line monetary gains as well. So here we've got a survey done by Humanitech that really shows some of the sort of more quantitative benefits that we can gain by introducing platform engineering into our organization. Things like being able to reduce wait times due to blocked environments, average deployment frequency going up by about 4 times, visibility and transparency across teams, onboarding time, especially for newer developers, decreasing because they're not having to take on so much of the cognitive load themselves, and lead time decreasing as well. So you can see there are monetary, clear, quantitative gains to be had from this as well. Now, that's not to say we're going to stand here and say platform engineering is the solution to all your worries and stresses. Because just like microservices aren't the answer for every application, neither is platform engineering. It's just a potential solution that you might want to consider. So we thought we'd put up this slide, which we thought was a really good summary of kind of what is good about it, what is bad about it, and what the challenges might be. So the fact that you get increased developer autonomy, reduced time to market, and that increased developer satisfaction are obviously all great benefits. But the challenge is, if you have a really, really large organization and you're only putting a couple of people on that platform engineering team, they're going to really struggle with that load. So it needs to be scalable. It needs to be appropriately sized for your organization to be able to build those sort of self-serving solutions. And there's other challenges as well, things like user authentication, being able to have alignment and standardization for those security compliance as well. As I said, the strain is on that platform engineering team, so you have to ensure you're making it the correct size for your organization. And it can be difficult managing some of the configuration and tools, especially if you have multiple golden paths within your IDPs as well. But just to give you a summary of things you might want to consider as you look at platform engineering. So, with that summary in mind, we've introduced what platform engineering is, how it can help with some of the developer struggles we face, what an IDP is, in this case the platform, and what an internal developer portal is too. So what tools can we use to actually get started with this?
Well, on the portal side, we first have reference architectures. For example, this is one from Humanitech, and you'll see that it's always divided into subgroups. Like this one is developer control planes, integrations and delivery, so CI/CD tooling, monitoring and logging, so an observability stack, and so on. You have as well the one from the cloud native grocery store, which Grace showed you in the beginning with the Where is Waldo slide. You have one from platformengineering.org as well. You have quite some reference architectures to look into. Then on the portal side, I think the market leader over there at the moment is Backstage. It's a CNCF incubating project, so it's part of the CNCF Compute Foundation. It's donated by Spotify, and it's an open framework to build developer platforms. It's centralized by, it's built by a centralized software catalog, and the most important thing is that it's highly flexible, so you can enable, disable quite some capabilities with plugins. The disadvantage of Backstage is that the disablement of these plugins is done through the source code of Backstage itself, which is React.js, so JavaScript library, which often leads to high maintenance efforts, and sometimes companies don't want to upgrade for this, which results in security issues. At Red Hat, we created a downstream project, still all open source, which is called Developer Hub. So a downstream of Backstage, which now is enterprise grade, so we deliver support on it. It's hardened. But most important thing is we created a midstream project, which was Janus, which was living in between Backstage and Developer Hub. And why was that? Well, we wanted to tackle the issue with the extensions, with the plugins. We created a framework to now enable, disable these plugins and configure them together with Backstage through YAML definitions on Kubernetes. It was a huge refactor on the Backstage source code. They didn't really appreciate it if we want to push it in the Backstage project, so we had to create a midstream project. Nowadays, they see the added value of the dynamic plugin configurations, plugin framework, so it's being moved to the Backstage project. So if you are researching for it, you'll see that the Janus project is deprecated, and that's the reason why. But why do this through Slideware if we can just demo how it looks like? So for the demo, we will have Backstage as developer portal, and as developer platform, we will have OpenShift, which you can see as an enterprise-grade application platform. It's integrations done for you on the vanilla Kubernetes cluster. We'll use Tekton, GitLab, Jenkins as CI tooling. We have Quay for image repository, DevSpaces as an IDE running on Kubernetes, accessible through the browser, and so on. Let's start with Backstage. You see that it's branded as Developer Hub, but when you open Backstage, it looks 100% the same. The only difference in between the community Backstage at the moment and Developer Hub is under the hood the way to configure it. One important aspect is already the software templates, or the golden paths, which Grace mentioned. And that is blueprints of applications to kickstart new microservices, new components. Let me quickly start one, and then we'll look into a definition. So if we want to bootstrap a new service, for example, a game we have, give it a name, and you link it to a cluster, a Kubernetes cluster. Why? We will automatically configure CD, so deployment configurations. So we will need to point to a Kubernetes cluster. We select an image registry. And we select a Git repository. For us, it's GitLab. You'll see no game repositories are created yet. Let me quickly create it. Now some steps are followed. I come back to the steps in a second as well. And that's some kind of automation process that needs to happen to kickstart the software template. This can take a minute, so while it's running,
especially on a conference Wi-Fi.
Indeed. Yeah. So how does the template look like? Well, in the end, it's a YAML definition with parameters and steps. Parameters are the form parameters that a user, whenever he wants to bootstrap this template, can fill, like you saw in the form I filled in a couple of seconds ago. And then steps, if it's readable, is some steps that need to be taken when you bootstrap it. For example, so you fetch the template code, you do some translation of parameters inside, you publish it to Git, you start CI templates, and so on. Let's see what's happened. So it is there. So now in GitLab, we should have the game repositories. They are created for us. And then an important thing here is that you can parameterize how it looks like. For example, in the Open Liberty one, and maybe Grace, you can explain what Open Liberty is?
Yeah, that's a pretty good idea. So if you've not come across Open Liberty before, it is a cloud-native runtime built to be very lightweight and modular and very, very performant. If you're interested in finding out more about it, it's essentially a very similar technology to Quarkus, implements very similar libraries and technologies like microprofile and Jakarta EE, as well as cool stuff like test containers and OpenTelemetry. And you can check it out on openliberty.io. It's all open source. Or you can follow us on social media. I run the social media, so I'll say hi if you come follow us. But check it out, Open Liberty, if you are interested.
So the template itself has a template YAML file, and it has a skeleton. And the skeleton is then the default application, the primer, depending on the organization, it has a different name. And this is now a parameterized default application. For example, this is the Open Liberty one, where we have a special file, don't worry about it at the moment, which is, for example, using these parameters to fill some metadata that can enable or disable tooling in Developer Hub into Backstage. Now, to get the CI/CD pipeline started, I'll do a quick change in the code base. For the ones that are not familiar with dev spaces, it's an Eclipse project that runs an IDE in Kubernetes, and it makes it accessible to the browser. Most of the time, I do it via there, but now with the unstable or slower network connection, I'll take less chances of things going wrong. Yeah, so change is pushed. So if you're interested, it looks like that. It has advantages, and that's that you don't need to set up a local machine with all the tooling around it. For example, Java versions, JavaScript versions, or Python versions. It's just there to run. Disadvantage, you need network connection. You need a connection to the cluster, to the Kubernetes cluster, in order to make use of it. Now back to Backstage. When we now select the catalog, we should as well have the game repository over there. And if everything went well, a working CI pipeline. Yeah, it's running. We'll come back to this in a second. Let's first check some other things. So here you have an overview of everything that's happening for this application. For example, on Kubernetes, you can already have a topology view. You'll see that everything is red at the moment. Yeah, CI/CD pipeline is still running. We don't have any image to deploy yet, so all topology views, our topology components are in an error state. You can link issues, for example, Jira, Trello, ServiceNow lists, dashboards into Developer Hub as well, or Backstage. And this has another value that whenever you are waiting for a CI pipeline, for example, to complete, you now can see what's happening in your sprint, which tickets need review, which tickets are still open to plan your work ahead. Most important one, or useful one, to my opinion, is the merge requests, the pull requests that are listed over here as well. Because my experience is whenever you have a pull request outstanding for your colleagues, it's you nag during stand-up that someone should review it, then you nag during lunchtime that they have to review it, and you have to nag in Teams. Now, whenever you have to wait a couple of minutes for your CI pipeline to run, you can easily see which pull requests are open, and you can already review one of them. So it removes a bit of the nagging within the development space. CI pipeline, I'll come back to that in a second, maybe on the CD part. This is a view for us on Argo CD. You have a couple of deployment tools. For us, Argo is the default. See that still progressing, it's still waiting for the container image to be pushed into the system. Two simple but useful integrations here is the API listing. This is documentation of the API just for this repository, and it's an open API one. So you can have the Swagger UI over here to, if security is set up properly, already try out some of the APIs. But useful stuff is that you have the listing over teams within the entire organization on one place as well. Again, whenever I need to integrate with another team's APIs, 9 out of 10, it's, yeah, you have to contact this guy, he developed it. And Murphy's Law, he's always in holiday whenever you need to reach him. So now you can you can search for APIs that are available. And you can already have a look at the definitions that are there without having to go to specific persons. Go back to the game. Same thing for documentation. Over here you have documentation linked to this repository, but you have an overall documentation section where you can list whatever is going on in your organization. Best practice, often organizations try to migrate all the documentation to a format that's understandable for Backstage, which is Markdown formats, but doesn't bring too much added value, because I think you all will agree, in the entire documentation space you have within your organization, if you have already 50% that's still relevant, it's a lot. So don't make the effort to do the other 50% in the migration path. Just make here local entry points to documentation. Say, for example, when we want to kickstart a new Open Liberty Quarkus Spring Boot application, these are the steps that we want you to follow for this and this reason, as you can find over here, here, and here. It will make it more easy that you don't have to rewrite everything in a format as Markdown. It's not always convenient to put all your documentation in, as this is just a starting point to go to wherever you want to go in the organization. Now on the CI pipeline itself, Grace already mentioned threads parts as well. We've implemented what we call trusted software supply chain, and that's that you have some authoring, security checking within the CI pipeline. On the first part, git clone, yeah, I don't think it's too exotic. I think most of the people know what's happening here. We package it, and then we can already start with source scanning. There's just SonarQube that already does static code analysis and some unit and integration tests. Then the first security-alike thing next to the static code scanning is building and signing of the images. Why signing? Well, Docker images and mirrors to Docker image repositories are often compromised. If you sign your images and you pass these signatures to your OpenShift or Kubernetes clusters, you'll make sure that only these images are running on your environment, which gives you already a next layer of security. Then there's some SBOM there are some SBOM processes as well, which extract the SBOMs from the libraries and put it into repositories that can scan for vulnerabilities there as well. For example, if you had the log4shell issue, that you can check which versions of log4j as left4j that are within the application. Then some ACS checks. Don't worry about it. ACS is a security tool that runs on OpenShift on Kubernetes to scan images at rest, images in their environments, and the entire environment as well on known vulnerabilities. And then we export the SBOM, and we sign the SBOM as well for the same reason as we were signing the images. With this tooling, you can as well sign git commits for the exact same reason, that you are sure that the one who committed, the one who's on the git commit, is really the one that committed. And then resync is just triggering an Argo CD sync. Some of the things that you can do with Backstage is listing a tech radar, for example, to see which languages, which Java language, Java version, JavaScript version, and so on are supported within our organization, which versions will be deprecated and which we are looking into, or to links like databases and so on. All these components can be configured to enabling or disabling through YAML definitions. So for every Backstage implementation, the UI will look different. And then whenever you want to do some automation, you have, for example, an orchestrator plugin, which as well takes YAML definitions to define a complete workflow. If you're familiar with Terraform, Puppet, Ansible, it's not there to replace these tools. It's there to, for example, in a conditional format, call the exact automation APIs that you want to run behind the scenes. For here, for example, we have a greeting API, which takes a language, let's say Spanish, and we run it, and then it should come back with a greeting in Spanish, if everything goes well. Run completed, but no greeting. Not everything can go well during the demo, right?
It's a live demo, right?
Yeah, okay, but then there, and as you could see in the workflow, workflow runs. No, and normally we should have the YAML definitions here too. And let's go here. So it's just all YAML definitions as everything that's happening within Kubernetes. Just for the people that already have some experience with Backstage, the way you configure it now looks like this, and this is OpenShift for the people that are not aware of it. Let me check. Okay, it's not loading all my namespaces. So you have to believe me, it's all via YAML definitions that you can enable or disable these plugins. Over here. But Grace, there is more than Backstage, right?
Yep, absolutely. So obviously we've talked about Backstage, we've talked about Red Hat Developer Hub as being that sort of enterprise level downstream component of Backstage, but there are other options to choose from as well. So if you've already got licensing or you've used these products before, these might be others to consider. Kratix works a little bit differently in that it uses contracts through Kubernetes to be able to set up those golden paths. But there are also other proprietary offerings available out there from companies like Port, Rody, Compass, and you can actually go to the internaldeveloperplatform.org/developer portals, and that will give you a full list of the different platform or portals, out there that you can make use of for your internal developer platforms as that sort of interface. Okay, so hopefully what we've shown you in this presentation is that we don't have to run away. Going back to that very first meme that we showed right at the very beginning, if you can remember back, where we were running away after building it. Hopefully we're not running away now. We're using IDPs to guide us forward confidently on our ships heading towards cloud-native technologies. In summary, we've discussed the fact that cognitive loads and demands on developers are ever increasing, especially as tools continue to develop and we continue to understand better evolutions of architecture and tooling that we can use for cloud native. But developers can be supported and helped through some of the concepts that we've introduced in this presentation. Platform engineering, internal developer portals, internal developer platforms, and those golden or paved paths that we also showcased. Now, it's important to note here that we just showed a demo example where we'd selected those individual components, those ingredients that we were talking about, and baked together our own platform. What that platform will look like and what those ingredients are is going to be different for every single one of you, because it really depends on your application, your organizational needs, and which tools you might have a particular need for or preference for. So it is going to be specific for your organization. But the nice thing is you can utilize the tools, the technologies, the roadmaps that are out there already in your own organization as an example to follow. So as I said, resources, because who doesn't love homework after a long day at a conference? So if you do want to follow up on this, I thought it might be helpful to give some examples of organizations that have gone through this. They've introduced their own IDPs, and these are some of the success stories from those organizations of how they went about that and what benefits they gained. Now, we've tried really hard here to try and pick a variety of different sizes of organizations, because again, we're not all Netflix. So hopefully there's an organization in there that you can relate to and maybe use as an example going forward. As well as that, there's also platform engineering communities out there that you can join or utilize the resources from. So there's a platform engineering guide from InfoQ that's quite helpful and short. If you want some more conference sessions that are platform specific, then you can visit PlatformCon's YouTube channel. The sessions there are from previous year's conferences, and they're only about 20 minutes long, so quite easy to consume and watch if you do want to see those. There's also a Slack channel and a weekly newsletter if you're interested in learning more about this. No, we've got 2 more resource pages. I just got so keen with all these URLs. Okay, so more resources here is some blogs from Martin and I about sort of the benefits you can gain. This is basically just a summary in depth of some of the slides we've shown today. So the difference between platform and portal, what tools you can use, and why IDPs matter. If you want to get hands-on with this technology, because obviously this was more lecture style, but if we're developers, we like trying stuff out ourselves. So we've got some useful links here. You can utilize the sandbox environment in OpenShift if you do want to try out Red Hat Developer Hub. You can also check out Open Liberty. We've got a starter project. That's the link there for it. You can get started in 10 minutes with that runtime. We've also got some tutorials, and right at the bottom here, Martin and I have given this talk as a workshop previously, so we have our workshop instructions there. You should be able to do everything in the sandbox environment for free on OpenShift if you did want to give that a go. It'll take a couple hours, so just a heads up on that one, but the others should be pretty quick to get started with. So, if you do want to continue this conversation, we know it's the end of the day now, so everyone's a bit tired and ready for happy hour, of course. But we do have an IBM booth, so feel free to come and visit at the IBM booth if you do want to have a talk about this. I'll be there all day tomorrow as well. So, if you miss out today, you've got all day tomorrow to catch me. Alternatively, we also have a Java community within IBM where we post about a lot of different cool Java subjects, so you are more than welcome to join us on there, on that Tech Exchange community. With that, we're basically at time, so that was good. I'm not keeping you from the beer and drinks afterwards, but thank you so much for listening. If you have any questions, we'll look at Slido in a minute. If you've not put them on Slido and you want to have a conversation after, that's totally fine. Alternatively, our contact details are on this slide, and you can reach out anytime after the conference. Thanks very much.